Good afternoon, everyone. Today, myself, Manoj P, Assistant Professor, working in at Vidyadhar College of Engineering, Department of Civil Engineering. Today, we will be discussing on transportation infrastructure. This is the second day related to transportation infrastructure and traffic engineering. In the last class, we discussed about the highway geometric design till super elevation. Today, we shall start with the radius of horizontal curve. What do you mean by horizontal curve? Horizontal curve is the curve which is directed in horizontal direction. Okay, either to right or left. The ruling minimum radius of the horizontal curve for a rolling design speed is designated by the capital V, and it can be expressed in terms of kilometer per hour. Normally, it is expressed in terms of kilometer per hour. R rolling means rolling radius. The equation substituted or derived for the radius of horizontal curve is capital V square divided by 127 E plus F. Capital V square is the speed in kilometer per hour. E is the super elevation and F is the coefficient of friction. F is the lateral coefficient of friction. Okay, if they ask you a question like this, the rolling minimum radius of the horizontal curve for a rolling design speed v kilometer expressed in kilometer per hour is, you are supposed to tell the formula. You are supposed to mark the correct answer. As I said, R is equal to V square by 127 E plus F. V square by 127 E plus F. So here the correct answer is option 2 or option B. Next, we will move on to the widening of pavement on horizontal curve. What do you mean by widening? Okay, here widening can be uh, widening is needed for providing extra width on the road for two purposes. One is mechanical widening, and the second one is psychological widening. What is mechanical widening and what is psychological widening? The term mechanical widening here, when a driver moves, okay, this is with respect to the condition of the vehicle. With respect to the condition of the vehicle, mechanical widening is provided. Here, when you maneuver, when you transfers your vehicle, okay, along the curve, then there will be some amount of off tracking. There will be some amount of off tracking. In order to avoid that, mechanical widening is provided. Psychological widening, yes, when the vehicle driver is moving at a higher speed, then in order to have better control over the vehicle, psychological widening is provided. So extra width over here is provided based on mechanical widening as well as psychological widening. Okay, extra widening we, the equation here is Wm, that is the mechanical widening, and Wps, that is the psychological widening. Okay, so Wm mechanical widening is designated or can be expressed as NL square divided by 2R, whereas psychological widening can be expressed as V divided by 9.5 square root of R. Here, N represents number of lanes, L represents the length of the wheelbase. As I said, mechanical widening is something related to the vehicle. N represents the number of lane and R represents the radius of horizontal curve. Here, psychological widening, as I said, it depends upon the driver's speed. V represents speed in kilometer per hour and R represents the radius of horizontal curve. Everything is expressed in terms of meters and speed is expressed in terms of kilometer per hour. Normally the value of L will not be given. Normally the value of L will not be given. Okay, it is assumed that the value of L is 6.1 meter to 6.0 meter. This is nothing but the length of the wheelbase. Now, they may ask you question based on this equation. Numerical problems also based on this equation. The formula for calculating mechanical widening WM is what? As I said, WM is equal to NL square divided by 2R. So the correct option is option C. Sorry, NL square divided by R. The correct option is option B. WM is equal to NL square divided by R. Okay, based on that equation, you may have numerical problems, and that will be asked for 2 marks. That will be asked for 2 marks. The design speed of a two-lane road is 80 kilometer per hour. When a design vehicle with a wheelbase of 6.6 meter is negotiating a horizontal curve on that road, the off tracking is measured as 0.096 meter. The required widening of the carriageway of the two-lane road on the curve is approximately what? That is nothing but they ask you to calculate the extra widening. How do you calculate? You will calculate using the equation WE is equal to mechanical widening plus psychological widening. What is the equation for mechanical widening? NL square divided by 2R plus V divided by 9.5 square root of R. V divided by 9.5 square root of R, where N is equal to number of lanes, L is equal to length of wheelbase, R is equal to radius of horizontal curve, V is the vehicle speed, and R is the radius. Okay, when we substitute, N here is 2, N here is 2, L is 6.6, R is R is not given. Okay, V is equal to speed 80 kilometer per hour and 9.5 square root of R. Okay, off tracking is given. Off tracking is given as 0.96. You just have to calculate. Substituting the equations, you will get the answer as 0.75. Substituting the values here in the equation, you will get the answer as 0.75. Okay, since the radius is not given, they have given the value of off tracking, so you can calculate. And let us come back to the last question. This is not the correct answer, sorry. And WNL square by 2R, NL square by 2R is the correct answer. Option C is correct. Next question: a two-lane road, one-way road of radius 50 meter is predominantly carrying lorries with a wheelbase of 5 meter. The speed of the lorry is restricted between 60 and 80 kilometer per hour. Okay, the mechanical widening and psychological widening to be provided at 60 kilometer are designated as WME 60 and WPS 60 respectively. Mechanical widening and psychological widening required at 80 kilometer are designated as WME 80 and WPS 80. The correct value of WME 60, WPS 60, WME 80 and WPS 80. That means you are supposed to calculate mechanical widening for 60, psychological widening for 60, mechanical widening for 80 and psychological widening for 80. Then you are supposed to tell the answer. Okay, here nothing wrong. You first calculate mechanical winding for 60 and mechanical winding for 80. Okay, these are the options. Okay, mechanical widening is the formula is NL square divided by 2R, whereas psychological widening, the formula is V by 9.5 square root of R. Sorry. Okay, here N represents the number of traffic lanes, L represents the length of wheelbase, R represents the radius of horizontal curve, and V represents the designated or design speed. Okay, substitute the values here. What is the value of n? N given as n is given as number of lanes. It is a 2 lane. The value of n is 2. The length of L is wheelbase as is given as 5 meter. So the value of L is 5 meter. R radius is 50 meter. So the value of R is 50. Okay, you will get the answer as 0.50 for mechanical widening 60, 0. For 80 kilometer per hour, for 80 kilometer per hour, you will get the same answer because here speed is not affected. Here both should be same, 0.5 and 0.5. Okay, now we need to concentrate on psychological widening because here speed is uh, considered. Okay, speed here we need to check for both 60 as well as 80. Okay, when we substitute 60 divided by 9.5 square root of 50, you will get 0.89, and when you put 80 divided by 9.5 square root of r, you'll get 1.19 meter. So this is how it is done. For mechanical widening, only once if you calculate, it is more than enough. Whereas for psychological widening, you are supposed to calculate for both 60 as well as 80 kilometer. Next is extra widening required for a 2 lane road at a horizontal curve of 300-meter radius, considering a wheelbase of 8 meter and a design speed of 100 kilometer per hour. Design speed of 100 kilometer per hour. Radius r is equal to 300 meter. This is simple. W is equal to Wm plus Wps. NL square divided by 2r plus V divided by 9.5 square root of r. N is given as 2 lane. N is given as 2. L is equal to 8. R is equal to 300. Again, V is equal to 100. Put the values here. Put the values here. You will get the answer as 0.82. Simple. This formula is very important. Most of the time, these type of questions are asked. Okay, here I have also mentioned that length of wheelbase is either 6.1 meter or 8 meter. But if in question they have given you this value, you need not consider this value. Only when they don't give in the question, you are supposed to either put 6 or 6.1. But in this question, they have given you the length of the wheelbase. So we need to substitute the value of L as 8, not as 6 point or 6.1. 6.0 or 6.1. This is something with respect to extra widening. Now let's move on to transition curve. What do you mean by transition curve? When there is a transformation of curve from straight to curve, when the road is the alignment is transferred from straight to curve, then you are supposed to provide the transition curve in between those curves. Okay, length of the transition curve. How do you calculate what should be the length of the transition curve? How much? What should be the rate of change of transition curve? Okay, here you have three equation by which you can calculate the length of the transition curve. Okay, you are supposed to keep the maximum of these three equations. One can be calculated by the rate of change of centrifugal acceleration. The second can be calculated by the rate of introduction of super elevation, and then you can calculate it by the empirical formula. Okay, equation for the rate of change of centrifugal acceleration by considering the acceleration into account. How do you calculate the length of transition curve? Here, acceleration means speed. Speed is V. Okay, V cube divided by C into R. Okay, C is equal to 80 divided by 75 plus V, and V here it is expressed in terms of kilometer per hour. Second is by rate of introduction of super elevation. By rate of introduction of super elevation. When super elevation is considered, what will be the length of transition curve? Okay, this is E. W is the width of the road. WE is extra width of the road multiplied by N. N is number of lanes. Okay, by empirical formula for plane and rolling terrain, this is purely empirical formula. 2.7 v square divided by r for normal terrain or plain terrain. For steep and hilly terrain, v square divided by r. We use these three formulas. We take the length of the transition curve as the maximum of whatever value you get from these three equations. Okay, here, now what is the length of the transition curve for a design speed of 80 km per hour in a horizontal curve of radius 240 meters? Okay, let us calculate by rate of change of centrifugal acceleration. Okay, this is centrifugal acceleration. When we consider, okay, it is 0.025215 v cube divided by cr. Okay, you may ask, okay, sir, v cube divided by c into r, how you got 0.215? You may ask, how did I get 0.0215 v cube? Here I have converted the values from meter per second to kilometer per hour. You will get 0.0215 v cube by cr. Okay, here c is equal to 80 divided by 75 plus v. You get 0.516 meter per second square. C value is expressed as meter per second square, because that is nothing but the centrifugal acceleration. Okay, r is nothing but the radius. You get the value as 89. When we consider empirical formula, when we consider empirical formula for plane and rolling terrain, when we here in the question they have not mentioned whether it is a plane terrain or a rolling terrain. Okay, so let us do it for both. You get 72 meters and 72 meters. Okay, so we're considering ls1, ls2 and ls3. You get 72 meters. Okay, ls2 here is e into w plus we into n. Since in this question, look here, since in this question, since super elevation is not mentioned, you need not bother about that. Okay, you need not bother about the one which is not mentioned. Only you can consider from condition 1 and condition 3. Since super elevation is not given, extra width of the road is not given, then out of those two equation, whatever value you get here, you can calculate. Here ls2 is not mentioned in the question, so you get the answer as 72 meters, out of which again in this question, in the options, sometimes in gate exam, here you may say that maximum of 1 and 3, but here maximum value is 89. Still 89 is not mentioned in the options. Sometimes in gate question paper, that option will not be mentioned. Then what you are supposed to do, nearest value whatever you got, you are supposed to put. So here the nearest value is 72 meters, so you are considering this value. Next is setback distance. Distance from center of the horizontal curve to an obstruction on the inner side of the curve is known as the setback distance. Here, this solid line represents the center of the horizontal curve. Here, this represents the starting of the obstruction. Okay, start of an obstruction on an inner side of the curve. On an inner side of the curve, assume that a vehicle is moving in this direction, then this will be the inner side of the curve. How do you analyze the setback distance? Here Setback distance can be analyzed in two cases: when the length of the curve is greater, and the other one is when the length of the curve is smaller than the stopping distance. Okay, here R alpha represents the arc length. Side distance S is equal to R alpha. Alpha is equal to S divided by R minus the radius of the curve. Alpha by 2 is equal to S divided by 2R. Okay, they are all derived equations. Alpha by 2 is equal to 180 S divided by 2 pi R expressed in terms of degrees. This radius is expressed in terms of degrees. Okay. When the length of the curve is greater than the stopping distance, okay, this is a single lane road. Okay, this is the continuation of that part. Setback distance M. You can have a look into this. Setback distance M is CF, and M is equal to OC minus OF. What is OC? O. This is O, and this is C. OC minus OF. You get the value of CF. Okay, here what is OC? OC is nothing but the radius of the curve R, OC. OF from here to here, OF is equal to R radius cos alpha by 2. Radius cos alpha by 2. So what is alpha by 2? What is this value alpha by 2, or this value alpha by 2? Total is alpha, total angle is alpha. Okay, from only this part is alpha by 2. Alpha by 2 is equal to 180 S divided by 2 pi R, and that is expressed in terms of degrees. We should be knowing these equations, at least this equation and this equation, in order to calculate the setback distance M. Okay, this is the condition when the length of the curve is greater than the stopping side distance S for a single lane road. Okay, for a multi-lane road, same length of the curve greater than stopping side distance, but for multi-lane road, how do you calculate the setback distance M dash? Okay, setback distance M dash. Here D is again extra. D is the distance between the center line of the road and center line of the inside curve. Equations, look here, R minus R cos alpha by 2. Instead of that, R minus, again you are subtracting it with D, capital R minus this another lane is there, no, that you are going to subtract width of that, R minus D cos alpha by 2. Here again alpha by 2 is equal to 180 S divided by 2 pi capital R minus D, whereas here 180 S divided by 2 pi R. Instead of R, wherever you have the value of R, you just subtract it, R minus D. You are supposed to subtract D from R. That's it. Both the equations will remain the same. For single lane road, it is R minus R cos alpha by 2. For double lane road, you are supposed to subtract D. Next is when the length is less than S. When the length of the curve is lesser than the stopping side distance, M dash is equal to, here F C. This is the setback distance from inner curve. Okay, here GC will calculate FC first, FG and GC separately. FG, this portion is FG, that is equal to S minus length of the curve LC divided by 2 into sine alpha by 2, and GC is the one which you calculated earlier previously, is equal to R minus R cos alpha by 2. Okay, this happens, this condition happens only when the curve is less than the stopping side distance. Okay, what I want you to do is, I just want you to learn this equation when they ask you when the length is less than stopping side distance. R minus R cos alpha by 2 plus s minus lc divided by 2 into sine alpha by 2. Okay, in that was for single lane road, and this is for multi lane road. Setback distance m is equal to cf. M is equal to cf is equal to, from here, o c minus of. Oc here is nothing but r. OF is equal to r cos alpha by 2. Alpha by 2 is equal to 1s ts divided by 2 pi r. Based on setback distance, they may ask you this type of question. Calculate the setback distance required for a two-lane highway having a radius of 200 meters. Total length of the curve. Length of the curve is LC. Distance between the center line of highway and center of inner lane is 1.95, and also the value of S is 340 meters. Yes, since it is a multi-lane road, because it is not a single lane road. Two lane means multi-lane road. You are supposed to use this equation. M dash is equal to r minus d cos alpha by 2 plus s minus lc divided by 2 sin alpha by 2. Alpha by 2 is equal to 180 s divided by 2 pi r minus d, which is equal to, you get as, this will be expressed in terms of degree, 34.7 degrees. Okay, m dash is equal to, substituting the values of r is equal to 240 and d is equal to 1.95, and alpha by 2 is equal to 34.7, s is equal to 340, lc is equal to 240. Yes, yeah, yeah, 240. You get the answer as m dash as 66 meter. Okay, here they asked you to calculate both stopping side distance as well as the setback distance. Look into the question. Horizontal circle curve with a center lane radius of 200 meters is provided on a two-lane road, two-way. The width of the two-lane road is 7 meters. Design speed for 80 kilometer per hour, that is capital V. The brake reaction time is also given 2.4 second, and they have given you both F, lateral as well as longitudinal friction, 0.355 and 0.15. In order to confuse you, they have given both the F values. Okay, the setback distance from the center line of the inner lane is what? In order to calculate this, in order to calculate the setback distance, you need the value of s, because you need to check whether that is less than s or greater than s. Okay, so what is the equation for stopping side distance? 0.278 vt capital V into t plus v square divided by 254 f. The value of v here is 80 kilometer per hour. It is given as 80 kilometer per hour. What is the value of f? F value here depends upon the speed. F value here depends upon the speed. And in case of stopping side distance, you are supposed to consider longitudinal friction, not lateral friction. You are supposed to calculate consider longitudinal friction and not lateral friction. Only when you calculate super elevation, you will need to consider the lateral friction. Okay, consider 0.355 and calculate the value of s. Here d is small d is also given in the question. Okay, r is given as 200 meters, r is given as 200 meter, whereas the width of the two lane road is 7 meters is given, and small t value is 2.4 second, 2.4 seconds, it is also given. Okay, when you know this value, substitute the values r as 200 meters and d as 7 meters cos alpha by 2, calculate alpha by 2, 180 s divided by 2 pi r minus the s value you would have calculated here. You'll get the answer as 8.10. Here, whenever you need to calculate the setback distance, you need the value of s. If s value is not given, you are supposed to calculate the value of s, or else you should be knowing what is the value of s for a speed of 80 kilometer per hour in order to get your calculation quicker. Next is vertical alignment. Horizontal alignment is done. Vertical alignment, we need to consider three criteria. One is gradient, second one is summit curve, and third one is valley curve. What do you mean by gradient? When there is change in the elevation with respect, when there is rise or fall with respect to a flatter surface, then you call that as gradient. Okay, or with respect to horizontal, then you call it as gradient. Here, it can be expressed either in terms of 1 in n or in terms of percentage. You should be knowing this. There are three types of gradient. There are three types of terrain: plain terrain or rolling terrain, or also mountainous terrain or steep terrain. For these three types of terrain condition, there are uh, three types of gradient. One is ruling gradient, limiting gradient, and exceptional gradient. Normally, a designer will design the gradient for rolling gradient, considering there is no other after effects. There are no other obstruction. When a designer cannot, or when a constructor cannot provide a ruling gradient, he can go for limiting gradient. That is especially when the terrain condition is not suitable, then you can go for limiting gradient. Only at some exceptional places, steep terrain or steep hilly region, then you can go for exceptional gradient. You should be knowing for a plain terrain what is the ruling gradient prescribed by IRC. Okay, it is 3.3 or 1 in 30 for a plain terrain. What is the limiting gradient? 5% or 1 in 20 for plain terrain. What is the exceptional gradient? 6.7% or 1 in 15. Similarly, for mountainous terrain, for limiting gradient is 6. For a steep terrain, rolling gradient is 6% or 1 in 16.7. This table you should be knowing, because you may get a question like this: what is the rolling gradient for a plain terrain or a rolling terrain? The options may be 1 in 30, 1 in 20, 1 in 15, or 1 in 16.7. When you know this, you can directly tell that it is 1 in 30. It's like this. Limiting gradient for a plane and rolling terrain is what is the percentage? So the answer is 5%. You can look here. Limiting gradient for a plane and rolling terrain is 5%. What is summit curve? Look, as I said, there are two types of curves. One is the summit curve, the other one is a valley curve. When you have the convexivity upwards, then you call it as summit curve. That means you go up and come down. There is a convexivity upwards. Okay, here there are two cases: when the length is greater than or equal to stopping side distance, and the other one is when the length is less than stopping side distance. When the length is greater than or equal to stopping side distance, this is the equation, derived equation: capital N square divided by square root of 2 capital H plus square root of 2 small h the whole square. When the length is less than s, this is equation 2s minus square root of 2 capital H plus square root of 2 small h the whole square divided by n. Here, what is n? N is nothing but the deviation angle or algebraic difference between the two grades. S is nothing but the stopping side distance. Small capital H is the height of the eye level of the driver above the road surface, and small h is the height of the subject or object above the road surface. Here, what should be the value of h, capital H, small h? Okay, it is similar to your side distance for SSD, and for SSD, capital H is equal to 1.2 meters and small h is equal to 0.15. Whereas for OSD and ISD, both capital H as well as small h is 1.2 meters. So this value, square root of 2h plus square root of 2 small h, is equal to 4.4 meters in case of SSD. In case of OSD, the same value is 9.6 meters. So now for stopping side distance, this will be equal to L is equal to ns square divided by 4.4. Here L is equal to 2s minus 4.4 divided by n. In case of OSD, L is equal to ns square divided by 9.6. Here in case of OSD, L is equal to 2s minus 9.6 divided by n. That was for summit curve, and this is valley curve. Here valley curve, when you have concavity or convexity downwards, we need to take into consideration of comfort condition, because when you provide valley curve, a comfort condition is very important. And also during night time, there will be probability of uh, less visibility, so you need to, with respect to headlight, so headlight side distance is also need to be taken into consideration. In case of valley curve, yes, for comfort condition, L is equal to 2 square root of capital N V cube divided by C, whereas this is constant or centrifugal acceleration. C is equal to centrifugal acceleration. Headlight side distance, this is with respect to side distance. Okay, one first case is L is equal to greater than or equal to S. Second case is L is less than or equal less than S. Okay, first case equation is L is equal to ns square divided by 2h1 plus 2s tan alpha. Second case, L is less than S, 2s minus 2h1 plus 2s tan alpha divided by n. Here, what is the value of h? What do you mean by h1? H1 is the height of headlight above the road surface. H1 is height of the headlight above the road surface. And what is this alpha? Alpha is nothing but the beam, headlight beam of a vehicle, at what angle it is inclined. Here H1, normally headlight will be placed at 0.75 meters above the road surface, and beam will be at 1 degree. So this equation 2h1 plus 2s tan alpha will be equal to 1.5 plus 0.035. Yes. Okay. This is the minimum length of the vertical curves. Directly, when they ask you what is the minimum length of the vertical curve for a design speed of 65 kilometer per hour, then you can say that it is 40 meters. And what is the minimum length of vertical curve for 100 kilometer per hour? It is 60. This is the values provided by IRC. Height of headlight above the road surface is 0.75 meters. Inclination of a headlight beam with a horizontal alpha in the valley curve is 1 degree. Minimum length of vertical curve for 100 kilometer per hour, as I shown you the table. With respect to the table, it is 60 meters. What is grade compensation? This is very important. While designing a hill road with a rolling gradient of 6%, a sharp horizontal curve of radius 50 meter is encountered. Compensated gradient at a curve. What do you mean by grade compensation? As per, in technical terms, look here. Normally, horizontal curves will be provided on a flatter gradient. When there is a gradient, that means when there is a steep rise or steep downward fall, then the grade should be compensated. That means whenever there is a horizontal curve, whenever you turn right or left, you cannot directly climb up or climb down. Then some amount of gradient should be reduced. Normally, for a design speed, rolling gradient is 6%. This 6% cannot be provided when you provide a sharp horizontal curve of 50 meter. That need to be reduced. Okay. The equation for grade compensation is that T plus R divided by R. R is the radius. Okay, it is 1.6%. Either you are supposed to reduce 1.6%, or here maximum grade compensation is 1.5%, that is 75 by R. Maximum this much amount can be reduced. So initially the gradient was 6%, you are reducing 1.5%. So finally the gradient will be only 4.5%. You are reducing the gradient from 6% to 4.5%. Why? Because of the introduction of horizontal curve. Because of the introduction of horizontal curve, you are reducing the gradient. Here, last two parts with respect to geometric design: lateral clearance and vertical clearance. What do you mean by lateral clearance and what do you mean by vertical clearance? Lateral clearance means in lateral direction. Lateral clearance means in lateral direction. Distance between the extreme edge of the carriageway to the nearest face of the structure. Here, what is the extreme edge of the carriageway? Extreme edge of the carriageway means your curbstone, footpath, from where your footpath starts. From where your footpath starts. From here till this point, that is the wall. Okay, that is the wall, or it is also known that it is also equal to normal shoulder width. Lateral clearance: distance between the extreme edge of the carriageway to the nearest face of the structure. Shoulder or also footpath, okay, they are known as the lateral clearance. Next is vertical clearance. Here, if you can look into the underpass from this point to this point, this is the vertical clearance. Minimum it should be 5 meters, or yeah, minimum it should be 5 meters height above the highest point of a traveled way to the lowest point of the overhead structure. What they may ask you a question like this: minimum vertical clearance as per the IRC, then the answer is 5 meter. Okay, you may got this is the last question. Last question. You may get a question like this. They will give you the gradient 1 in 25 meets with the ascending gradient of 1 in 20. A valley curve need to be designed for a vehicle traveling at 90 km per hour based on the following condition. Okay, here they have given both headlight sight distance as well as comfort condition. Gradient is also given N1 and N2. N1 is 1 in 25, N2 is 1 in 20. Here capital V is 90 km per hour. Okay, you need to calculate for both headlight sight distance condition as well as for comfort condition. Here beam angle is also given 1 degree, and headlight height of the headlight H1 is also given 0.75. Longitudinal friction F is also given 0.35. Small t is also given 2.5. They have asked you to calculate the length of valley curve. As I discussed, you are supposed to use both comfort condition as well as headlight sight distance condition. L is equal to 2 square root of nv cube divided by c. Okay, when you substitute the values, n is equal to 1.1 divided by 25 minus 1 divided by 20, that will give you the value of capital N. V is also given, C is also given. Substitute the values, you will get the answer between 1.6 to 106 to 107. Uh, this will be your answer. Look here, they may ask you for 2 marks or 3 marks direct question without giving you the option. Last question. We shall wind up after this. The crest vertical curve joins two gradient +3 and -2 for a design speed of 80 km per hour. Corresponding stopping side distance is also given. Okay, the height of the driver's eye and object, this is capital H, small h. The curve length to be provided is what? First, we'll consider L is smaller than S. L is equal to 2S minus square root of 2 capital H plus square root of 2 small h the whole square divided by N. N is equal to deviation angle, that is plus 3 minus of minus 2. You'll get 5%. Okay, N is equal to 5. S is equal to 120. H is equal to capital H is 1.2. Small h is 0.15. You will get the answer when you calculate the value of L. You will get the answer as 152 meters. This question was discussed. So this is the end of the geometric design of highway. In the next class, we shall discuss about the railway engineering as well as uh, airport engineering and traffic engineering. Last part. This is something with respect to highway engineering. Next, we'll discuss about railway uh, and airport engineering and traffic engineering. Thank you.